Hello everyone, welcome to 1045 Engineering. We are here with yet another video in Grind 75, a Better Blind 75 coding series. Let's jump to today's problem. So today we are going to solve linked list cycle. We have to find out if there is a cycle in the linked list or not. Let's jump to the problem statement and we'll see how we are going to approach this problem statement. Okay. So last time we have solved balanced binary tree. Today's linked list cycle. Just to give a review for the users who are coming for the first time, we are solving all the questions from the Grind 75 list. So it contains all the questions from easy, medium and hard. It will cover all the questions that are required for advanced coding interviews and will cover all the different topics in the interviews. If we showcase the topics, we can see linked list cycle is from linked list, then we have binary tree, binary search tree, graph, binary search tree, stack, queue, arrays, graph, heap, this way. Okay, yeah. So let's check today's problem. It is linked list cycle. So given the head of a linked list, determine if the linked list has a cycle in it or not. So what happens is we are given a linked list. You can see 3, 2, 0, 4, and after 4 it is pointing back to 2. We have to find out whether a cycle exists or not in this list. So as we can clearly see from the image, a cycle does exist. After -4 it is returning back to 2, and if you go next 0, next -4, next 2, right? Now just take a minute and think of a approach that will solve this problem. Okay, so this is a really easy problem. We'll be using 2 pointer approaches for this one. We'll call them slow pointer and fast pointer. So why slow and fast pointer will work for this is, we are going to assign 2 pointers. We are going to start them from the head. Let's say both of the pointers are started from the head. Let's understand from the example. So we have a slow pointer. Okay, we have a slow pointer, and similarly we have a fast pointer. They are both at 3 in the beginning. Now we are going to move our slow pointer by 1 value. Okay, so 3 will move to 2, and we are going to move our fast pointer by 2 values. Okay, so 3 will move to 2, and this fast pointer will move to 3 to 0, right? 0. Then in next iteration, slow pointer will move to after 2 0, and fast pointer from 0 will jump 2 places, -4 and then 2, so it will reach 2 here. Okay, slow pointer is moving 1 by 1, 3 2 0. Fast pointer is moving by 2 values, from 3 to 0, from 0 to -4 and 2 again. Okay, now in next iteration 0 will move to -4, slow pointer, and fast pointer will jump 2 places, 0 -4, and will reach -4. Okay, if slow pointer and fast pointer come out to be at the same exact position, they have the same value, that would mean that there is a cycle in the loop, there is a cycle in the linked list. If in running this procedure, going 1 by 1 and going 2 at a time for fast pointer, if at any given point in time fast pointer reaches the null or the slow pointer reaches the null, right, that would mean the end of the linked list, and then there is no cycle in the linked list. Okay, let's start coding. Okay, yeah, let's start coding. So we'll initialize 2 pointers, as we already discussed. 2 pointers, slow and fast, right? Both initially pointing at the head of the linked list, right? So we can say list node slow for the slow pointer is equal to head, and list node fast is equal to head as well. Head is a starting node and list node is the data type for this. Okay, now we are going to start the traversing process, going one by one and going two at a time for slow and fast pointer respectively. So traverse the list with two pointers that we have, right? Slow moves one step at a time and fast moves two steps, right, at a time, as we already discussed. Okay, so we'll say while slow is not equal to null, because if it's equal to null, that means we have reached the end, and fast is not equal to null. Also, we are going to check, since fast is jumping two places at a time, we are going to check for its next one also not to be null. So fast dot next is not equal to null, otherwise we can get null pointer exception. Okay, now we'll say move, let's not write the comment here, we'll write it like this: slow is equal to slow dot next. Okay, move slow by one step, move slow pointer for clarity, move slow pointer by one step, right? Similarly, fast is going to move two steps at a time, so fast is equal to fast dot next. That is why we are checking whether fast is not equal to null and also fast dot next is not equal to null. Let's say do they have an example here? Yeah, for this one, let's say after 4 there was end, the fast pointer goes from 3 to 0, and after 0 it wishes to jump after 4, which is already null. So we have to check for the next as well, so that next to next is already null. We don't go from -4 to next, which does not exist at all. Next of -4 would be null for a simple list. That's why we are checking for fast not equal to null and fast dot next not equal to null. For slow, since it is moving one at a time, we are checking only for slow not equal to null. Okay, we'll write for this as well: move fast pointer by two steps. Okay, we have understood the approach that if the cycle exists at one given point in time, slow pointer and fast pointer will come at the same node and will know that a cycle exists. They can merge on any of the node -4, 0 or 2, but they'll come to the same node at one point in time if a cycle exists. Okay, now we'll check if there is a cycle, right? The slow and fast pointers will eventually meet at the same node, right? So we'll simply check if slow is equal to fast, we can simply return true. This is cycle detected, right? As in this case, slow was at 3, fast was at 3. When we started, slow moved to 2, 0, -4, fast moved to 3, 0, 2, -4, and at -4 node they came together, so we can return true that a cycle has been detected. But after running through this whole while loop, if there is no cycle, the loop will eventually end and we can simply say return false. No cycle detected. Just for clarity, let me put one more comment here. If the fast pointer reaches the end of the list, of course, because fast pointer will reach before the slow pointer, or becomes null, there is no cycle, right? Let's run it, and we have already taken the fastest approach, so it must give us some good time complexity. Okay, let's submit. Great, beats 100% of the users with Java. Okay, So this has been achieved in O of n time complexity, because you can see we are going to traverse each node at only once. And for this, if the cycle exists, eventually we'll figure out the loop. So we cannot say that we are going to do it O of n square. The time complexity would still remain O of n. And plus, when the cycle does not exist, in O of n will fast pointer will reach in O of n by 2, which is eventually O of n, to the end of the list, and will detect there is no cycle and will return false. Okay, so with this we mark our linked list cycle problem statement complete. And that is all from today's video. Thank you everyone. If there are any comments, please let me know in the comment section, or if you have another approach that is better than this one, please let me know in the comment section. Thank you. Please like, share and subscribe.